One of the few things that makes our Earth unique from other planets in our solar system is life. But life on Earth wouldn't have been possible if there was an absence of this one factor. Because of the absence of this factor, planets like Mars and Venus lay lifeless, as many believe. This factor of Earth is vital for life. So, let's take a flight around the Earth in the second episode of the new series, Planet Earth, and find answers to a few curiosity filled questions such as: what is this factor? Why is it vital for life? Let's start from the very first question, which is: what is this factor? This factor is Earth's atmosphere. It is like a blanket made of layers of gases wrapped around the Earth because of Earth's gravitational force. It is composed of nitrogen, 78%, oxygen, 21%, argon, 0.9%, carbon dioxide, 0.035%, water vapor, and even smaller amounts of other gases. We can understand Earth's atmosphere by understanding its layers. It is divided into five main layers, which are the exosphere, thermosphere, mesosphere, stratosphere, and troposphere. Let's take a look into these layers. Exosphere is the outermost layer of the atmosphere, extending from about 600 kilometers, or 375 miles, to 10,000 kilometers, or 6,200 miles above the surface of the Earth. Satellites orbit in this layer. Its upper end symbolizes the end of outer space. In this layer, atoms and molecules escape into space, just like the way a popping popcorn escapes from your cooking pot. Beneath the exosphere is a transition layer called the thermosphere. It extends from about 53 miles or 85 kilometers and 375 miles or 600 kilometers above the surface of the Earth. In this layer, temperature increases with altitude. The rise of temperature is caused by the absorption of ultraviolet light and X-rays emitted from the sun. Now, you might wonder, because of its high temperature, it can cause severe burns to a human. But you will be shocked to know that this is not the case. Despite the high temperature, this layer of atmosphere would still feel very cold to our skin. But why? Because the high temperature indicates the amount of energy absorbed by the molecules in this layer. The total number of molecules won't be enough to heat our skin. It's also the layer in which we can see some of the most beautiful phenomenons occurring in the sky, such as aurora borealis, northern lights, and aurora australis, southern lights. Beneath the thermosphere is the mesosphere, from the Greek for middle. It ascends from 50 kilometers to approximately 85 kilometers above the surface. In this layer, temperature decreases with distance from the surface of the Earth. Temperature in the upper mesosphere is lower than 70 degrees Celsius. Shooting stars or meteors can be found in the mesosphere because meteorites that strike the Earth are usually burned up in this layer. Earth's highest cloud type, noctilucent clouds, can be found in polar regions in the mesosphere. The name of the clouds, noctilucent, means luminous at night because they are so high up in the atmosphere that they are lit up by the sun for most part of the night. They seem to be quite recent phenomena, having only been observed and noted from the end of the 19th century, and scientists are still pretty unsure exactly what causes them. The layer immediately below the mesosphere is the stratosphere, ascending to heights of 50 kilometers above the Earth's surface. Commercial airlines tend to fly quite low in the stratosphere in order to avoid the turbulence they face in the layer beneath stratosphere, known as troposphere. Although not so frequently, nacreous clouds can be seen in the stratosphere in polar regions. They beautifully brighten the night sky as they reflect sunlight several hours before dusk and dawn. Air in the stratosphere is heated by ultraviolet radiation, which is absorbed by ozone particles found in the stratosphere. Many of the ozone particles are located high up in the stratosphere, where they form the ozone layer. A great abundance of ozone higher up in the stratosphere means that temperatures become hotter with increasing distance from the surface. In the 1970s, levels of ozone in the atmosphere were found to be decreasing. Harmful substances, such as chlorofluorocarbons, were found to be the reason behind ozone depletion. The discovery of a hole in the mid-1980s led to a worldwide ban on chlorofluorocarbons by 1996. Research shows that the ban has had a positive effect, as the rate of ozone depletion seems to have slowed down significantly. Ascending from the surface to a height of 8 kilometers at the poles and 18 kilometers at the equator is the troposphere, from the Greek for mixing. Conditions in the troposphere vary from region to region and time to time. The state of the atmosphere in any given place at any given time is called weather. Weather is caused by differences in the amount of energy an area receives from the sun, which leads to variations in atmospheric pressure, temperature, humidity, wind, and cloud cover. The greenhouse effect, responsible for insulating the Earth with vital thermal radiation, occurs mostly in the troposphere, where there is an abundance of greenhouse gases, particularly water vapor and carbon dioxide. The troposphere becomes less dense with height, meaning that there are fewer particles to absorb the heat, with the result that temperatures in the troposphere decrease with height. Clouds, comprising tiny droplets of condensed water vapor, form mostly in the troposphere. Moving on to the next and last question, why is it vital for life? I think we already found the answer to this question until now. But let's again recall the reasons that make the Earth's atmosphere vital for life. The atmosphere, particularly the ozone layer, which is high up in the stratosphere, absorbs most of the sun's harmful ultraviolet radiation, protecting life on Earth. The troposphere traps heat through the greenhouse effect, preventing extreme temperature fluctuations between day and night, and keeping the planet warm enough to keep the life going on. Cloud formation, an essential part of the water cycle, is done in the troposphere, which is vital for life. The atmosphere, particularly the mesosphere, plays an important role in preventing widespread damage to life by burning meteoroids before they reach the Earth's surface. Not just this, but the atmosphere also provides us with breathable air, as it contains carbon dioxide and oxygen, along with other important gases that are essential for life. Without an atmosphere, Earth would be like present-day Venus and Mars, barren and uninhabitable, with extreme temperature fluctuations and no protection from harmful ultraviolet radiations.